Nuclear energy is powerful, but it comes with a significant challenge: managing the waste it produces. This waste, known as nuclear or radioactive waste, is a byproduct of the energy production process. It remains hazardous for thousands of years, making its safe storage a critical issue. So, what happens to this waste? Let's explore how we safely store radioactive materials and ensure they don't pose a threat to our environment or health. When nuclear fuel is used in a reactor, it becomes highly radioactive and generates heat. This spent fuel is initially extremely dangerous and must be handled with utmost care. Right after use, spent fuel rods are placed in deep cooling pools. These pools are specially designed to contain the radiation and heat emitted by the spent fuel. The cooling pools are filled with water, which acts as a shield, reducing radiation and heat. The water not only cools the spent fuel but also provides a barrier that protects workers and the environment from radiation. These pools are typically located on-site at nuclear power plants and are heavily monitored to ensure safety. Spent fuel rods remain in these cooling pools for several years, allowing their radioactivity and heat to decrease to safer levels. This period can range from a few years to several decades, depending on the specific requirements and regulations of the country where the nuclear plant is located. Once the spent fuel has cooled sufficiently, it is transferred to dry cask storage. This method involves placing the spent fuel in massive steel and concrete containers, known as dry casks. These casks are designed to contain radiation and prevent any release of radioactive materials into the environment. Dry cask storage is a robust and secure method for storing spent nuclear fuel. The casks are built to withstand natural disasters such as earthquakes and floods, as well as potential human threats. They are stored in secure facilities, often on the grounds of the nuclear power plant, and are monitored continuously to ensure their integrity. For long-term safety, high-level nuclear waste is buried deep underground in secure geological formations. This method, known as deep geological disposal, involves placing the waste in specially designed repositories located hundreds of meters below the Earth's surface. These repositories are chosen for their stable geological conditions, which help isolate the waste from the environment. Deep geological repositories are engineered to contain and isolate nuclear waste for thousands of years. The waste is placed in corrosion-resistant containers and surrounded by multiple layers of protective materials, such as clay and rock, which act as additional barriers to prevent any potential release of radioactivity. Some countries have also developed advanced technologies to recycle spent nuclear fuel. This process, known as reprocessing, involves separating usable materials such as uranium and plutonium from the waste. These materials can then be used to produce new nuclear fuel, reducing the amount of waste that needs to be stored and making nuclear power even more efficient. Reprocessing not only helps manage nuclear waste, but also extends the life of nuclear fuel resources. By recycling spent fuel, we can extract more energy from the same amount of raw material, making nuclear power a